so let's talk about Bohr models. Okay, so let's talk about Bohr models. So we're going to draw these. So these are a visual representation of an atom in a 2D space, so we can draw them. So we're going to first draw the nucleus. Then you're going to write the element symbol, the number of neutrons and the number of protons in the nucleus. You're going to draw your first energy level. And then you can draw the electrons and the energy level according to the rules. You're going to make sure as much as you can draw them in pairs. And then you're going to keep track of how many electrons are left to use. This is more complicated than it needs to be because we're going to look at the rules for Bohr energy levels. Level 1 will hold 2 electrons. Level 2 will hold 8, 3, 18, 4, 32, 5, 32, 6, 18, 7, 8. And these line up perfectly with your quantum numbers for your orbital maps. So a trick to writing these is to complete an orbital map. Then you're going to add up the electrons per level, those, superscripts, and then you can get the total electrons per level. And then you know how many are in each ring. And then in the nucleus are your chemical formula, your atomic mass, protons, neutrons, and electrons. In the nucleus, and there's a ring around the nucleus, and there's no electrons in the nucleus ever. So that your nucleus ring is by itself. So let's look at how we might draw a Bohr model. So we're going to draw a Bohr model for carbon. The atomic number is 6. The atomic mass, I gave you carbon 12, is 12 grams per mole. So from that 6, we know we have 6 protons, 6 neutrons, and 6 electrons. Remember, your atomic number is your protons and your electrons. Your neutrons is mass minus your atomic number. We are looking, the number of energy shells or how many rings you're going to have is really the row number you're in or the period you're in. Carbon's in 2. So we're going to put 2 in there, and the number of energy shells, the number of valence electrons, we know carbon has 4. The number of valence electrons are always going to be on that outermost shell. So the first thing we're going to do is write an orbital map for carbon. So ring 1 is your quantum number, is 1. So we have 1s2 because the first full orbital in ring 1 is 1s2. So for the first ring, we will have 2 electrons. Ring 2, we have 2s2, 2p2, full orbital, then a non-full orbital because carbon's in the second row of the p block. Second column of the p block. So we add 2 plus 2, which gives me 4. So we would write in 1 ring with 2 electrons and then 1 more ring with 4 electrons. And I would put 2 on one side and 2 the other. So let's talk about nickel. Nickel is Ni. We have, and for most of these, I will be giving you like a whole number. Some of these I was just doing not in whole numbers. So we have nickel, we have 28 electrons, 28 protons. That's our atomic number. For nucleus, we had 58.69 minus 28. So we got about 31 neutrons. If we weren't using a whole number, we were using the average atomic mass. So we would fill it in as, nickel's in the 4th row. So we write 4 levels. So it's 1 is 1s2, 2 is 2s2, 2p6. So we just add them up. 2 plus 6 is 8. 3 is 3s2, 3p6, 3d8. So we have 18. And then we have 4s2, which is 2. Everyone with me so far?
Yeah.
Okay. Then you would draw, I'm sorry, my drawings are not the best. Nickel with your electrons, protons and neutrons in the center. Look, there's a ring around it. We'd never put, this is a nucleus. No electrons go in the nucleus. No electrons go in the nucleus. You draw a secondary ring. So then you put in a ring around the nucleus with 2, because these are your shells, right? So if you look, level 1 has 2, level 1 has 2. Level 2 is 8, level 2 is 2, 4, 6, 8. Sorry, I went the wrong way. Level 3 has 16, level 3 is 2, 4, 6, 8, 10, 12, 14, 16. Level 4 has 2, level 4 has 2. So your quantum numbers relate directly to your rings on a Bohr model. Does that make sense? Okay, so let's look at germanium. You know, germanium, the nucleus is Ge. It's 72.61 grams per mole. You're not always going to be using the average atomic mass. If you are given a whole number like calcium 20, please use that 20. You look up germanium, there's 32 electrons, 32 protons. It's got about 41 neutrons because we had a round instead because we didn't have a full number. You write your orbital map. You always write an orbital map for this. It'll make your life so much easier. You add up your electrons on each quantum number. Those are your electron shells, 2, 8, 18, and 4. 2, 8, 18, 4. Obviously, my Bohr models leave a lot to be desired. I apologize. Any questions on any of this? Okay, no questions? So draw the Lewis dot structure in Bohr model for sodium. Draw the Lewis dot and Bohr model for chlorine for some practice. I'll give you just a few minutes.